we're now going to do the RLC parallel circuit, and so the diagram would look like that: RL, then C. This right here I sort of mangled. It's supposed to look like basically a bunch of loops. So this is what we're working with here, and so the big question is what is in common. And so for things in parallel, voltages. So when we do our phasor diagram, we draw the voltage first, and that stays in parallel. So let's erase this and go on to our phasor diagram here. So we'll do our axis in red, draw the voltage there. So that is the voltage that works for everyone. So that would be the EMF, and that is the voltage across the resistor, and the voltage across the capacitor, and the voltage across the inductor. Current, that's the other big thing we need here. So let's go for, I just did that color. All right, so current, we'll do black. I know that for the resistor, the current is in series with it. So that's the current across the resistor right there. And now, Eli. So for the inductor, the voltage leads for the inductor. Oops, wait, sorry. We have the voltage already. The voltage leads for the inductor. And so this would be the current for the inductor. For the capacitance, I know that the current comes first, so this is the current for the capacitance. Again, we don't know whether IC or IL is larger. It all depends upon the value of C and L. And so what we'll end up doing here is that we will assume one is bigger than the other. Again, I'm just going to make the assumption, assume IL is greater than IC. And so I'm about to erase this, and I'm going to draw my first bit of addition there. Draw my axes. Draw my voltage. And now my currents. I know I sub R is there. And then assuming this is going to be I sub L minus I sub C. That is a right angle there, despite the way I drew it. And so the current, if you think about the parallel circuit here, I'll just quickly sketch it up here. That the current coming out of the power supply is equal to the current going through each of these, the sum of those. Sum of the currents going through each component should equal the current coming out of the power supply. So I'm going to add my currents here in my phasor diagram. I'm going to add them together to get the current going across out of the inductor. So that current right there, and we will go for orange for this one, that current right there is basically pointing in that direction, and that's I sub power supply. So I know that the current across the power supply squared is equal to the current going across the resistor squared plus IL minus IC squared. And so that is now at the place where we need to clear the screen, and we are getting ready to find the impedance again. So I have the current from the power supply squared equals the current across the resistor squared plus IL minus IC squared. We employ Ohm's law and the Ohm's law variations, and so this is epsilon squared over the impedance squared. Recall if V equals IR, then I is equal to V over R. That should be equal to the voltage across the power supply, across the resistor, I mean, over the resistance, plus this I sub L here is the voltage across the inductor. Oh, sorry, that should be squared. Over the inductive reactance minus the voltage across the capacitor over the capacitive reactance squared. All those voltages are the same, so I can factor it out. Matter of fact, I'll put in that intermediate step. So I have epsilon squared over Z squared equals VR squared over R squared plus V, well, actually, they're all the same there. So V squared times 1 over x sub L minus 1 over x sub C squared. The voltage is all the same. They cancel out. And what we are left with is going to show up on the next screen. So I have 1 over Z squared equals 1 over R squared plus 1 over x sub L minus 1 over x sub C squared, which is 1 over R squared plus 1 over omega L minus omega C squared. That's 1 over Z squared. And therefore, Z equals, we have to take the reciprocal and the square root both. And so this becomes 1 over the square root of 1 over R squared plus 1 over omega L minus omega C squared. And so that's the impedance for the parallel RLC parallel circuit. And the next one we do is going to be more complicated. So prepare yourself for that. Just get all excited and get ready to rejoice.